Dear ladies and gentlemen, welcome to the next talk. It's the talk for myself. My name is Siegfried Hackel. I would like to present you something about the digital calibration certificate, but at first I would like to show you our DCC homepage. It's very easy to find. Just type into your web browser ptb.dc/dcc and then you get this page. On this page you find a lot of informations. For example, here in the publications section you will find even tomorrow or in 2 days the proceedings of the 4th International DCC Conference. So then you can just look here for all the publications. Please feel free to use this. The other point I would like to show is we have many other informations about the DCC. Here are tutorials where you have videos in the most important languages with subtitles in French, Spain, German, English, Russian, Chinese, and whatever, where you can just look for such videos. And here in the wiki you find many informations about what are the informations which are inside of the elements and attributes. So please use this DCC homepage for questions. This is very important. So now I would like to start with my talk, and therefore I would like to start. Here is once more the web page, and now I would like to at first to give you a small overview of the PTB. PTB is a German Meteorological Institute. It is founded in 1887, so it's very old, the oldest NMI in the world, and it is founded by science from Helmholtz, and that's his lab. You can see it's a physical site, a historical physical site, this building. And also from industry by Werner von Siemens, who is the most famous industry partner at that time. And there is a name which mostly is not known, but I would like to remember him because he is the founder for the legal metrology, which is important for everybody of us, even if you are not a metrologist. But if you are a human being and you have to pay, for example, for current or for water or for something you would like to buy at the butcher or in the supermarket, this guy has founded the legal metrology, so that there is a correct handling. That's very important. So, but something more, which is very important, I think, this is a cradle of quantum mechanics, where the first measurements concerning quantum mechanics are done, and where the quantum mechanics just grows up. Albert Einstein makes one experiment here in this building. So it's a very famous site, and if you think about quantum mechanics, many people are surprised when I tell them without any quantum mechanics nothing will work anymore. And we will also see something from my colleague from NIST afterwards, where he will describe a lot of things by NIST on a chip. I would like to show you also our adversary board. It is from people from calibration service, from industry, very important, and from science, but also from associations and from ministries. And I'm very proud to show you a list of very famous people from the adversary board, where physicists well known, Wilhelm Conrad Röntgen, the first man who gets the Nobel Prize in physics, or Max Planck, or for example Albert Einstein. And nowadays we have in our board Klaus von Klitzig, Walter Hensch and Wolfgang Ketterle, three very important people from physicists. Locations of metrology. Well, it's not only here in Nuremberg or in Brunswick or in Berlin. We have had a lot of locations of metrology because metrology is nearly always and everywhere. We have about 100 countries in the world, which presents about more than 98% of the what is earned. And this is very important. And this story is only important, is only possible because that metrology makes it possible that a kilogram is always the same all over the world. How is it realized? Well, it is realized by the meter convention. The meter convention has made a contract long years ago with and the CIPM and BIPM plays an important role in this. And you see there are calibration pyramids here, and not only in one country, but in every country which is part of this community, there are such calibration pyramids. And this ring means, oh sorry, that's bad. This ring means that on the highest level of metrology, these NMIs are making key comparisons. In this way, it is accepted and possible that all over the world, 1 kilogram is 1 kilogram. That's very important. And now we just look for one pyramid for a nation. This is a typical look, and Wolfgang Melzer has shown this before. On top is the NMI, but the NMI just makes about 5,000 or even 10,000 or more or less calibrations per year. Why? These are very small number of calibrations, because these are very important and high accuracy calibrations. And for the industry, we need much more calibrations. And so in Germany, for example, we have millions of calibrations per year, which goes upside down from this pyramid. And at the product area, we have really a lot. Maybe we have had a talk today in the morning where a guy which has his desk in this direction said they have company calibration certificates. So a product has a calibration certificate when you buy it. These are millions. And how are they transported? Well, they are transported paper-based, and that's terrible. And the story for the DCC, which starts in 2017, is to go away from paper and just go to another way. And here you see the principle of the DCC, which means that the output is no longer paper, but it is machine interpretable stuff. And how does this DCC works in principle? Well, it has three most important legs. The first leg is norms and standards. And here you see all the necessary norms and standards which are must be fulfilled. For example, it should be in the SI. It should be SI units. But if you have to make a calibration, for example, in inch, no problem. But you must define it. Another point is the VIM, which is a vocabulary for metrology, or GUM for the uncertainty, codata for the very well known natural constants, 70025, and a lot of other standards which are necessary to build up a calibration certificate. The second part is a structured system of how to store the data. And we have split it in 4 rings. The first is the administrative data, then calibration results, comments, and documents. And maybe you have seen it with the talk of Michael before what he has shown a lot about it. And then we have XML as an exchange format. The reason why we use XML is that it is internationally accepted and harmonized for more than 25 years. And in nearly every software you will find XML. For example, if you just look for the Microsoft products, you will find XML inside since more than 10 years, and so on and so forth. So XML is always and everywhere, and it's also in the DCC. And you can work with it very nice because it is optimized for documents. So what are the advantages of the DCC? The first, which is very clear, is it is no media discontinuity anymore, which means that the calibration lab needs no paper anymore. And for example, the company Fluke, which is a very important company for electromagnetic things, for multimeters and so, they need about $1 million per year for paper. And they're very happy that they don't need it anymore. Or in the transition form, it is, you can decide in which kind of transition you send the calibration report or the calibration certificate to your customer. And inside of the factory, it's very important because then you are able to work with these informations. I will just show you something later. The next point is that it is clearly defined. So everybody who would like to know what is stored in which element is able to find it because it is globally unique and clear. It is well established. And the next important point concerns Industry 4.0. You know that we are in a revolution time, and therefore it is very important that we are able to give our support for this part by using such things like RAMI or the asset administration shell. Safety and security is very important because if you work in this way with digital documents, you will never lose them. A lot of paper is lost because it finds behind the desk or behind the whatever. And then it's away and you find it maybe 30 years later when somebody retires and the next one comes. Yeah. So it's not very good. And with these modern mechanisms, you are able to make a long-term preservation. This kind of information can be read in 100 years, no problem. And it's also integral and authentic. So you know who has signed it, and you can check if it is manipulated. And last but not least, and that is something which we can show really very clear, is that it is economically, even for the industry, and the industry partners are those who are the customers, are the clients from all of us who are working with calibration. So last but not least, you can say DCC is globally harmonized, it's secure, it's resilient, it's auditable, and I will show you why. Here you see a workflow, a typical workflow for calibration. For example, here you have a cantilever and a distance block. And what you do at first is you just write down here what kind of standard do you use, what kind of cantilever do you use, the serial number of the cantilever, the name of the lab, who is making the job, and so on and so forth. The next step is that you log the data, which means that you measure all the different points and all the ambient conditions you need. And then you start analyzing the data. And I have never seen now that there are some analyzing processes by hand. All these things are done in a machine. So all the data which are necessary for the report, for the calibration certificate, all data are inside of IT systems. But what you do is you make a printout or even a PDF, and that's a little bit stupid, or isn't it? And the only thing what we would like to change, we wouldn't like to change the whole chain, but we would like to change that the output is also in the IT system available form. And now we have to look what are the differences between these things. Well, just you see there's only a difference on the right-hand side. So we just look only for this. And if we just look for the older version, you see you need a Word template or a Word template, then you bring it to PDF, or you also need a LaTeX template or whatever. You bring all the informations from there to PDF or to paper. If you make PDF, it's digitization. And that's very nice. In the English language, you have the difference between digitization and digitalization. In Germany, we don't have this difference. So we just write down to point it out that it is not digitization, but it's digitalization and digital transformation. It's much more. So then you can, I would like to present once more the utility model, which was presented by Michael also, which is a model from an ISO subgroup, and they have shown what is, how much, how IT is inside of a document. And well, in paper there is no IT inside. If you use a PDF, so you can store the information on a computer or on a computer system, on a file server or whatever, so it's much better, but you cannot analyze the informations. So you need a machine-readable document, for example, XML, that you are able to read in the informations. But if you don't know what is stored on in which element, then it's only readable, but you don't understand. So it is very important that you are able to execute these elements, so that you are able to know what does the value 42 means. Is it what is the unit, and what is what is meant by this unit? Otherwise, you don't know what is meant. And to get it in a more important form, then it is important to have a machine-readable and interpretable content, which means that you are able that a computer understand what is meant by 42 volts, for example. That it is meant that it is AC, and it is the difference between the point 1 and the point 2 of a current. And then at last you have the machine controllable content, and with the machine readable and interpretable content, which means good practice, then you are able to join to this. So please remember, this is a very important point. This is now, I would like to show you the national quality infrastructure, which is typical all over the world for a nation. Here you see what has happened between the different players. We have the national metrology institutes, we have the national standard bodies, and we have the national accreditation bodies. This picture is not by me, but it is made by Gouache et al. From the World Bank. And these three organizations makes it possible that these organizations are able to work, because the accreditation body and the national standard body gives them all the information how to work, and that they are working in the right way by the accreditation bodies. And here you see what is the benefit. Here you have companies, or you have also not only companies but also organizations who should work in a way that it is a benefit for the customers and for the general public. So it's a very important point. What is missing now is calibration. Calibration can be seen here, which means that the National Metrology Institute gives the norms and standards to the calibration lab, to the accredited calibration labs. And they give their information to testing laboratories and inspection laboratories. And so, if this is always done, then they are able to give all the information to the enterprises so that we have benefits for the consumers. This is a whole story until, let's say, for about 5 years. Now we have the situation that we are able to give the informations also in a digital form. So the NMIs are able to give the definitions of units in an electronic way, and also the NMIs can give their informations about the calibration to the calibration labs, and they also can give it to the inspection and testing labs. And so also inside of the industry, they can use this very important informations. Why are these important steps? Because there is no error anymore by the transfer. This is very important because, for example, the pharma industry has a necessity to check that there is no error when they import the data set from the paper, from the PDF to their IT system. They have to control it by a 4-eye principle. So they need about 3/4 of an hour for one calibration certificate to make sure that it is an error-free transportation of the data from paper or PDF to their IT system. 45 minutes, and the error rate is 1.5%. So it is not error-free. And that's a real big problem if you just look for medical products, for pharmaceutical products. If there is something wrong, it's really, really critical. And that's the reason why pharmaceutical industry is very interested in implementing the DCC. I will show later. Here you see now the story of the DCC, and you see that it starts in 2017, and at the end of 2017 we make the first publication to this. And in this publication you can also see this picture I have shown you with these 3 legs. Then we make a lot of workshops, and here the first international project starts, where we have a EU-founded program. It's called SmartCom, this project, where we ask together with our NMI partners all over the world, what is a necessity for the way for going digital. And here a lot of informations are stored. In the meanwhile, we start with a project, GEMIMEG-I, I will show afterwards GEMIMEG-II, where we would like to know what are the necessities to look more in detail from the industry partners. Because we wouldn't only look for the NMIs, for the high level, but we also would look for the industry partners which do the job so that we have a benefit for the general public. And meanwhile, we have another project. It's called International Standard Accident Number. It's a medical project where we find out that if we analyze the information from sensors maybe 50 sensors are in a modern car, or even much more, or the sensors here from a smart clock. If we can use the informations, if there is an accident, then we put this to the shock room, that the doctor knows what has happened. It is a really benefit for the patient, and they can examine from the sensors if there is a broken leg or a shoulder or whatever. And so many informations can be sent to the hospital, to the shock room, where there are many informations before, so that it is very important for the people. Then you see here GEMIMEG-II. That's a huge program I show later. And you also see there are a lot of congresses and conferences during the whole time, until 4 international DCC conferences with more than 1,000 participants from around about 100 countries in the world. And I've told you that the pharma industry is very interested in the DCC, and we have had some tests, some proof of concepts with the pharma industry, and the result is that the pharma industry will now start working with DCCs. Now I would like to give you a small overview of GEMIMEG. What does GEMIMEG mean? GEMIMEG means Gemini for digital twin, metrology global. And if you need a buzzword, otherwise you are not able to get funding. Yeah? You need a word. And Gemini was occupied by a steel project, so we have to use another name, and this is our acronym now. It is a lighthouse project of our Ministry of Economic Affairs and Climate Action, and the funding is about 50 million euros. So it's a really huge project, and it ends at the end of last year. And here you see the partners of the project, and once more you see the name Siemens, but you also see other well-known companies as Zeiss or Fraunhofer, as Bosch. And there are also other companies like Valeo. Valeo is a company for the automatic, for the carless, for the driverless car driving. And then we have others which are more or less in the region of house sensors. And then we have specialists for IT security. That's T-Systems and the University of Siegen. These are the hidden champions concerning IT security. And also it is necessary to look what are the judgments saying if you have to go to court with such a thing. And therefore we have the University of Kassel. They are the specialists, the hidden champions concerning to do the things right, so that you are on the best side on the court. And PTB. And here we also have associated partners, and there you see we have the standardization bodies in Germany, the accreditation body in Germany, the the pharmaceutical industry, and so on and so forth. And a lot of organizations, Roder and Schwarz, for example, also a very famous company concerning measurement and security. And all these informations from the GEMIMEG project I can tell about several hours, but I would like that you please go to our website where there are many of the publications. There you will see a lot of things. And in the near future, we will also represent informations I will show at the end of my slide. If you just make such a work, it is important that you speak with all the people from the national infrastructure. And So we ask our accreditation body what they are thinking about the DCC. For 2 years ago, they say it's very well, it's fantastic, we can work together. That's also the reason why we just have the possibility to work with accreditation bodies together. And the same story was also heard by the European accreditation bodies, which is assumption of conclusion of all the accreditation bodies in Europe, and the same also for ILAC, where we just show at a meeting together with the chief meteorologist of Fluke and one guy from DAX, how it works, and they say DCC is very welcome. And that's the reason why I would like to show you a small video, which is from DAX, where you can see the importance of the working together with the DCC. And therefore, please pay attention for this video. You can find it in the internet.
As the German accreditation body, DAX, we are the National Accreditation Authority. We play an important role in Germany's quality infrastructure. Trade and industry are increasingly digitized and pursue various types of digital transformations. This means that customers of conformity assessment bodies also expect digital services in these areas, which is why we are also contributing our part. As an accredited conformity assessment body, you will be able to apply for your unique accreditation symbol that is issued and provided to you by DAX as a digital version. This enables you to offer your industry and business clients your attestations in a digital, machine-readable format, as so-called e-attestations. In this way, the values from each test report or calibration certificate can be processed directly, ultimately reducing costs, saving time and increasing efficiency. German accreditation body, DAX, ensuring trust with e-attestations. Apply now for your unique accreditation symbol.
So a very important thing, the accreditation body makes it possible that we are able to work with a digital form of a calibration result or report or certificate or whatever. That's very important, and they have shown also in their small video that you can pick up information outside of the DCC. This is very important for the industry partners because their sensors don't have so much storage that they are able to store all the information from the calibration certificate, but maybe they only need some few informations which are very important for a good work. So then you can make a transfer of these informations directly to the sensor with your and then you have these informations inside of the sensor, and that's very important. So now I would like to go to another point, which means that we have discussed about good practice. The reason why we need good practice is that the DCC is made in such a way that everything which has something to do with calibration can be built up. So things from acoustics can be built up, things from the mass, from the length, or for radiation, everything can be built up inside of the DCC. And so we need a harmonization inside of the community, how it should be built up. And therefore I have a very nice example that this is not done before, but even they can do it before, but they don't do it. And here we have a typical problem in the digitalization process, that things which are not done before appears now. There exist very nice stories. I can tell you something about our start with SAP in the PTB. why it doesn't work from the beginning, that it stops. For example, we have in Germany, we have 5 code postal letters. The postal number has 5 digits. But before 1993, it has 4 digits. And when we start to import all the old data sets from the PTB, from the old source to the new source, SAP, it stops because there are sometimes 4-digit postal codes used. So it's not a digitalization problem, it's a problem on the other hand. And here I would like now to show you a problem which you can see if you look for a key comparison of a mass piece. I've shown you at the beginning this circle where the NMIs are just making such key comparisons. There was a mass piece which was sent around the world to different NMIs, and they should send back the calibration certificate. And here's the result only for the ambient condition, where you normally think it is very easy that the ambient conditions for a mass piece calibration should be it should be very simple. You need temperature, you need the humidity, and you need the air pressure. These 3 things you need. 3 very simple things. And just look for this terrible sheet. Yeah? This has nothing to do with digitalization. It's a real problem that they haven't done that job before. But now they are, it is a good way to harmonize this. And that's what is done by good practice, that the community has found a way how they write down the information. So, and if they do it, then you will get the good practice, which was also shown by Michael. Now I would like to show you something about data exchange. Just look for this calibration lab, which is part of a company. It's a company A. And the company A has to calibrate this machine. And they do it for the customer in the industry. Yeah? And then after the calibration, you must know that, that's very important, you must know that really every calibration lab uses their own software. They always have a company internal format, find it out how to make their calibration. And now the industry partner would like to have all the information also in IT system, so that the IT system of the industry partner is able to use these informations. What will happen? Well, the company A says, oh yeah, you can use our internal format. Why not? It's no problem. So we train you a little bit so we understand what is, how it works, and maybe you can buy our software so that you are able to understand what we are doing, and so on and so forth, so you can get all the information concerning this calibration out of our company A internal format. So far, so good. But the real world is a little bit different. There exists not only company A, but there also exists company B. And they have another company, in this case, company B internal format, and the same story starts again. And so this industry partner here has to buy a lot of software, has to train a lot of people concerning the company internal formats of their calibration labs to get the informations which they need for running the problem, their processes. That's not good, because this format here is not standardized. It's only the format of a company. And so, if there comes an auditor, he will not believe these information. And if you just look for more than 2 partners, this poor company here gets a data format explosion. Yeah? They have to buy a lot of software and so on and so forth. What is the solution? The solution is, don't change the company A internal format, because it is okay for the company. They have optimized their processes, but make a transfer to the DCC format. And then transfer the informations with the DCC. And because the DCC is globally harmonized, it's secure, it's resilient, and it's auditable, you are on the right and on the secure side, even if you go to court. Though it's much better that this will be done. And in the pharmaceutical industry, this trend just starts. So what is the next? So if you just look, then every, that's the final version maybe, but a lot of informations for the industry partners are then in a format which is standardized, where they get all the information they need in a secure way. Another important point is that the digital product path becomes more and more important here in Europe, but not only in Europe, also all over the world. And inside of this digital product path, many very important informations about the product, for example, for an electro engine, are inside. It's no longer enough to know which kind of electric motor it is. It is it's not so many informations are lost. And so it is important that also the DCC can be a part of this digital product path, because it is very important to know what is the status of the asset and what is the behavior, the long-term behavior, and so on and so forth. And here this is also written down. And the next point is Digital Test Certificate, DTC. The Digital Test Certificate, over here this is in the wrong way. It's a red D and TC is, is black, sorry. The Digital Test Certificate is the next step we are just working on, because it's the same standard. It's the 70025, which is important for calibration and for testing. And here we are just working together with German colleagues concerning test laboratories. This is the reunion of independent test laboratories in Germany, Verband unabhängiger Prüflabors, and PTB. And there we check, for example, for Legionellas in water. That's very important for the health, even for hospital or for living rooms for older persons. And this is a very important point. And this should be, or the aim is to digitalize the whole process until the end of this year, and we are just working on it. But also for battery chargers, it's very important, because battery chargers are playing a very, very important role for the climate change, and therefore we are just working on this too. And the basis is one common language for certificates in metrology, because if you just write down the address of a customer, it is independent if it is a test certificate or a calibration certificate or a certificate for reference materials or a certificate for conformity or whatever. So we are just working on this. And this is the abbreviation of it, it's DX. And if you just have looked for this roadmap of the DCC, you can see that we are working a longer time on this. And with this language, we are able to write down every a problem concerning metrology. This is a picture you have seen before, which is also in the first publication. And now I would like to give some more points. What is now the where we are now? The precise calculus and with the help of DCC and DCC tools will be written in a DCC toolbox. That's one of the last steps of the GEMIMEG-II project. And I think we will finish in the next quarter of the year. So maybe we are able to present it in August 2024. And this will be also shown on the DCC homepage. Then another very important point is the DCSI reference point. You have seen that also the meter convention is working on the transition from the analog to the digitalization. And so it is important that the paper-based SI brochure becomes digital. And if it is digital, the process is just running, then it is very easy to integrate this here on this place. It's all preserved. The next point is what I have told you before, the DX language, which is important for the basis for every metrological certificate. We are able now to have formulas for execution. So if you have a DCC with inside a form and the formula is inside, then you can calculate with this formula. So it's a step to AI. And last but not least, which is very important, is that you have a digital calibration request or general request for the laboratory that they know what they should do. This is very important, for example, for the pharmaceutical industry, because they are strongly regulated and they need this. It is very important for them that they are able to show to the auditors what they have said, what the calibration lab should do. For example, in the temperature region for the pharmaceutical industry, the region from, let's say, 30 to 50 degrees is very important. And so they can say, please make the calibrations and this also. And then they can write it down to this DCR. So that's nearly the finishing of my talk. But before I will finish, I would like to show you another video, because not only DAX has made a video, PTB also has made a video. And that's what I would like to show now.
Many companies, such as drug manufacturers, receive proof that their scales have been calibrated by an accredited calibration laboratory in the form of a paper calibration certificate. In pill production, for example, raw materials and finished products undergo different weighing processes, always using calibrated scales. After production, the pills undergo a final inspection. Every pill is weighed, and this is also done using calibrated scales. We assume that scales work properly if they have a paper or PDF calibration certificate. Generating either version requires roughly the same amount of time, and both can contain inaccuracies. It is time to retire paper certificates in favor of an error-free solution. An international team, coordinated by PTB, has created an excellent solution to this problem: digital calibration certificates, or DCCs for short. Digitalizing the certificates reduces the number of errors to practically zero.
A DCC contains all of the information required, such as for ISO 17025 in a structured form.
The file is in XML format and cannot only be read, but also interpreted by machines if jump labels are available. That means, for example, a marker for the jump from machine readable to machine interpretable data. A DCC minimizes human transfer errors and allows error-free and automated processing. Machine-readable certificates ensure that the error rate is reduced to 0.
Since processing is automated, measurement data sheets, raw data, or a configuration file can also be integrated into a DCC.
The DCC's well-ordered source code is thus the key to significant time saving. Roughly 45 minutes can be saved per calibration, which not only reduces costs, but also increases efficiency. The advantages of DCCs versus the paper and even the PDF versions are obvious. Cost-intensive qualified staff are relieved from administrative tasks. The DCC is significantly less prone to interference, thus increasing the reliability of the calibration system. Although we have used scales as an example here, the DCC can, of course, be created for any calibrated measuring device. The introduction of the DCC is greatly appreciated at the national and international level. To summarize, DCC's many advantages include increasing efficiency, reducing the workload of staff, accelerating calibration documentation, minimizing interference, and fulfilling strict international requirements.
Yeah, thanks a lot. This picture, Earth rising, maybe you remember, which was made by Apollo 8. It was one of the most important photos in the world, and the photograph, the astronaut Anders dies last week, and so please remember him. He makes a very good job by making this photograph, because it shows how sensitive our world is, and we must be taking this into account for our global work. And one small part of this is the DCC, and is always other things which we will see today. Thanks a lot. Do you have any questions? So if not, oh, that's very nice here. If not, then thanks a lot for your interest, and we will continue in about 5 minutes. Thank you.